So in this demo, we're going to look at collisions. This is Newton's cradle. So let's look at a collision of one of these metal balls onto the others. So in collisions, we've seen that conservation of momentum applies. So momentum is mass times velocity. So when I release one of these objects, it will have momentum. It has a mass, it has a velocity, and it will collide. And that momentum has to be conserved. So you might see that as a result, some of these balls will come out on the other side. So let's try that, see if conservation of momentum applies. Well, yes, true, right? So there is momentum conservation, but here's the thing. There is only one of these objects that's hitting and only one that comes out on the other side. So why is that? If you're trying to conserve momentum, if this has some momentum, you might wonder, well, both of these could come out and together they can make up the momentum of this, right? So that's a possibility. But what's happening here is these collisions are elastic. These are metal balls. So when they collide, elastic collisions, conservation of energy applies. So when this object collides here, it has a certain amount of kinetic energy that it has, which transfers over to another object. So that's why it has to be 1 to 1 or 2 to 2. So if you tried two of these objects, and you'll notice that two pop out on the other side, and that's because it's trying to maintain the same amount of kinetic energy. Let's try 3. As you can see, you start off with 3, 3 come out on the other side. So Newton's cradle is a good example of conservation of momentum and the conservation of energy.